Epicon tutorial.
Dear listeners, we want to solve a nonlinear initial value problem by Adm decomposition method today. The initial value problem is as displayed on the screen. So, for the Adm decomposition method, as we know, we start by writing the differential equation in operator form. So, in an operator form, the differential equation becomes Ly equal to y prime minus y squared. Then L is a second order operator, and then it is inverting. L can be written as d squared dx squared, and then its inverse, which is assumed to exist, can be written as a second order integral operator. We apply L inverse to both. Let's call this equation 1. So we have L inverse L equal to L inverse y prime minus L inverse y squared. So we now want to, so simplifying this, we have y of x equal to L inverse y prime minus L inverse y squared. So using the initial conditions, we are going to have our initial condition to be expressed as this. We have y of 0. We also have y prime of 0. So plus L inverse y prime minus L inverse y squared. Then further simplification gives, since y of 0 is 0, so the whole of this will be 0, plus y prime of 0 is 1, so this will be x, plus L inverse minus L inverse y squared. By Adm decomposition method, the initial conditions of the source term are written as the 0th term, while other are written as the recursive relation. So as a result of that, our y naught, the 0th term is x, and then the remaining terms are written as simply as L inverse y prime minus L inverse y squared. Since both terms are nonlinear, we are going to apply Adm polynomials to decompose it. So, and that can be written as yn plus 1. So let's represent y prime as an minus, and let's represent y squared as b subscript n. So in one of our previous videos, we have explained how the Adm polynomials can be obtained. So for this nonlinear term now, which is represented as an, so we have for an, so when n is 0, this can be written as y naught prime. Then for a1, this can be written as y naught y1 prime plus y1 y naught prime. Then when n is 2, that will be a2 equal to y naught y2 prime plus y2 y naught prime plus y1 prime. Then for bn represents y squared. So when n is 0, b naught will be y naught squared. When n is 1, b naught will be 2y naught, so y1. When n is 2, b2 is equal to 2y naught y2 plus y1 squared, and so on and so forth. So more of this can be obtained. Now, to continue the solution, so we have our recursive relation yn plus 1 equal to L inverse an minus L inverse bn. So at n equal to 0, y1 will be a naught. So this will be a naught minus L inverse b naught. And that will be L inverse our a naught as given above. This is our a naught, y naught prime. Then our b naught, y naught squared. So in that case, we'll have for a naught, y naught prime minus our b naught is y naught squared. And this means that L inverse, our y naught is x, so this is the x of x minus L inverse x squared. So integrating this twice, so y1 x dx minus x squared dx. So if we integrate this, y1 becomes x raised to the power 3 over 6 minus x raised to the power 4 over 12. So quickly, when n is 1, y2 will now become L inverse of a1 minus L inverse of b1. So from the Ademian polynomials here, this is our a1 and then this is our b1. So substituting that here, we are going to have L inverse into our a1 is y naught y1 prime plus y1 y naught prime minus L inverse 2 y naught y1. So from there, we can have the integration as here. Our y naught is x, then our y1 is x raised to the power 3 over 6 minus x raised to the power 4 over 12 dx. Then double integral for this. So that will just be 2 dot x into x raised to the power 3 over 6 minus x raised to the power 4 over 12 dx. So differentiating and integrating and then simplifying, our y2 will give us 1 over 30 x raised to the power 5 minus 1 over 40 x raised to the power 6 plus 1 over 252 x raised to the power 7. So collating the results together, plus y1 plus y2, and this will give us x raised to the power 3 over 6 x raised to the power 4 over 12 plus x raised to the power 5 over 30 minus x raised to the power 6 over 40 plus x raised to the power 7 over 252. So this is the result of the initial value problem. Of course, more terms can be obtained. Thank you for listening.